it says write the reaction for the first and second ionization of C, and separately write the reaction for the first and second electron affinity of C. So essentially this question is to remind us about what the difference between ionization energy is and electron affinity is. So ionization energy is the energy required to take an electron away. If it's the first ionization energy, is the energy required to take the first electron away. If it's the second ionization energy, the energy required to take the second, so on and so forth. Electron affinity is the energy sometimes required and sometimes given off when something gains an electron. Okay, so sometimes you actually have to put energy in for something to gain an electron. Other times energy is given off. So that's basically how it works. So IE1, the ionization energy 1 of carbon. By definition, carbon has to be in the gas phase. And we need to take an electron, whoa, what am I doing? An electron away from carbon. Well, what's left when we take an electron away from carbon? It's carbon positive in the gas phase because it lost an electron. For the second ionization energy, it's the energy required to take the second electron away. So it's already carbon plus in the gas phase. And we're going to get something plus another electron. Well, what's going to be the charge on carbon if it loses a second electron? It's going to be carbon 2 plus, and it has to be in the gas phase. The gas phase thing is just by definition. Okay, so that is basically how it works. Let's look at the electron affinity, the EA1. This is the energy required or given off when it gains an electron. So again, carbon has to be in the gas phase, and this time we're going to add an electron to it. All right, what's going to be left when we add an electron to carbon? We're going to end up with C minus in the gas phase. We could add a second electron, electron affinity 2. We start with C minus in the gas phase. It's already gained 1 electron. We add another electron to it, and we get C2 minus in the gas phase. And theoretically, we could add all the electrons in the universe to this single carbon atom. Obviously, that's not actually possible, but theoretically, you could write, the 999 millionth of these things. So that is basically how this works. You need to know the difference between ionization energy and electron affinity. So the energy required to take an electron away, the energy required or given off when an electron is added. Ionization energy and electron affinity.